All right. Yep. Uh, Today I want to do some very easy, uh, like Java oriented interview prep. Um, I'm gonna make a small list. Uh, so I have a rough outline of what I need to do, what I need to know for the interview, and I would like to go through those stuff. Um, so I have questions which is gonna be relevant to the interview, and I'm just gonna go through them one by one, talk a little bit about Java, read about it. Um, that's for lead code. Sorry guys, that's for lead code. Yeah, now it's good. Yeah. So question number one: private, protected, public. Um, for members, that member. So if none of the keywords private, protected, or public is specified for a member, it is only accessible by other classes of the same package. So very simple, Java package. Java package. Okay. Package in Java is used to group related classes. Think of it as a folder in a file directory. We use the packages to avoid naming conflicts and to write a better maintainable code. Packages are divided into two categories: built-in packages, packages from Java API, and user-defined packages, the packages that you create. Get rid of this. Packages that we create, built-in packages. The Java API is a library of pre-written classes that are free to use, included in the Java development environment, JDE. The library contains components for managing inputs, database programming, and much more. The complete list can be found at Oracle website. Library is divided into packages and classes, meaning you can either import a single class along with its methods and attributes, or a whole package that contains all classes that belong to the specified package. To use a class or package from the library, you need to use import keyword. All right, that's um, mm, yeah, base Java API built-in packages laconic. We have Java Lang package, which has core classes, string, math, object, and so on. Java util, which is collections, dates, and utilities. We have Java IO for input and output streams, files, and so on. Java NIO, new IO, buffers, channels, and so on. Java Net for networking, Java SQL, JDBC database access, Java Time for date time API, Java Math, which has big integer, big decimal, Java security, cryptography permissions, and so on. We also have Jakarta. This is probably enterprise and edition or something, serverless persistence. Um, yeah, like in Java, should a class be a single file, and a file should include only a single class? This is one question that I have. Um, so in Java, you should have one public class per file. File name equals class name. A file can contain multiple classes, but only one may be public. Inner classes don't need separate files. Usually one file, one class. With This is a clean way of doing Java, but why only one? Why only one? So actually Java requires that public class name matches the file name, so the compiler and JVM can find it easily. If multiple public classes existed in one file, the compiler wouldn't know which one should map to file name. Non-public classes don't have this restriction, so you can put many in one file, but only one public. It's a design choice to enforce clarity and predictable lookups. Difference between public, private, and protected keywords. Yeah. So think about packages. Package is like a folder in a file directory. It contains different Java files. Each Java file should have one public class, because otherwise you wouldn't be able to compile it. The compiler has to know, the compiler and JVM have to know mapping between file and public class. Public modifiers makes it visible everywhere. Private makes visible only inside the same class. Protected visible in the same package, and subclasses even in other packages. Package protected, visible only within table summary, quick memorization, no, like inside the same class. Show me examples. I also want to do a little project. If I have time, I must find time. You have class base visible everywhere. Only inside base, new base, system.out.pub. Alright, this is doable. Be priv, not accessible. Be protected in same package and same package. Do you need getters? Makes sense. And two different same package and subclasses, package and subclass. So protected keyword makes it visible, package and subclass. This subclass can be in other package, but all right. Another question, side by side, the rules test base keyword. Are getters and setters for private members. Yeah. What else? Yeah. Java OP concepts. Classes and objects class. Easier. OP is easier. What the? Faster to execute. I'm not sure about this. Provides a clear structure of the programs. Dry, don't repeat yourself, and makes code easier to maintain and debug. OP makes it possible to create full reusable applications with less code and shorten development times. About what the procedures or methods to perform operations on data, while of different programs about creating objects that contain both data and methods. Classes and objects are two main aspects of object-oriented programming. Another example: so a class is a template for template for an object. An object is an instance of the class of a class. When individual objects are created, they inherit all the variables and methods from the class. More about class and objects from the class. All right, classes and objects. Java is an object-oriented programming. Create a class, keyword class, public class. We create a class named main. Create an object. In Java, an object is created from class. We already have created a class from the main. I have a main, yeah, main system out. Okay, with the new keyword, specify class name keyword new. To create the object of main, specify the class name followed by the object name. And so this is a class name, object name, and new. Keyword new. What does new do? Operation scope. What does new do? Java keyword new. So in Java, new does two things. First, allocates memory for an object on the heap and calls the constructor of the class to initialize it. New person Alice allocates person object, runs its constructor. Reference P points to that object. Without new, you can't create most objects for literals like string hi. So new returns a pointer, right? So in Java, there are no row pointers. Returns a reference to the object in heap memory. That reference behaves like a safe pointer. You can pass it around, compare it, or use it to call methods, but you can't do pointer arithmetic to or access raw memory. New object on heap reference. What is Java reference? Or reference? So my interview is going to be pretty introductory, I think. A reference in Java is an abstract handle to an object in memory. So a reference in Java is an abstract handle to an object in memory. Think of it as an address, like a pointer, but safe and opaque. You can't see or manipulate the actual memory location. All non-primitive types, string, arrays, user classes are accessed via references. Example, P1 and P2 are references. Alice, they both refer to the same person object. Changing through one affects the other. Since the object itself is shared, in store reference is managed pointer to an object controlled by the JVM garbage collector. Do you want me to also show? Okay. Classes and objects. So this is pretty easy. Attributes. Term variable for x in the example. It is actually an attribute of a class. Or you could say that class attributes are variables within a class. So this is a class attribute. It is, so yeah, those are not given public, private, or protected keywords, so they are only accessible by other classes of the same package. Other classes of the same package. So like using protected, much like so yeah, like this makes a lot of sense. If you don't use private, it's gonna be accessed in the same package. If you use protected, it's gonna be used by subclasses, even if the subclass is in another class. Okay. What is a method signature? Class methods, Java methods. Attributes. Static or public. Static void, static. An example, we create a static method, which means that it can be without creating an object in the class of the class, unlike public, which can be only accessed by objects. Static. It's a class attribute. Class is gonna have this. Access methods with an object. Methods. Method is a block of code which only runs when it is called. You can pass data known as parameters into a method. Methods are used to perform certain actions. Why use methods? To reuse code. Create a method. Method must be within a class. The signature, parentheses, in Java, method, static method belongs to the main class. Call a method. Method. Don't we have signature? All right. Java method signature. Function signature. Method. Signature in Java consists of method name and parameter return types. Parameter, types, and order. Access modifiers. Access modifiers. Names, parameter, types, and order. Types, order. Types and order. Order is also really important. Name of the method, and parameter, types, and order. Even parameter names, but technically they have the same signature. Okay. Java methods, method parameters. Yeah. Now, method parameters. Information can be passed to methods as parameters. Parameters act as variables inside the method. Parameters are specified after the method name. Inside the parentheses, you can add as many parameters as you want, just separate them within a comma. The following is the method takes string called theme as parameters. When the method is called, we pass along the first line, which is used to string called fName as parameter. When we pass along first name, which is used inside method to many multiple parameters, methods will be false. Yep, you're not old enough, you're not old enough. It's inside methods. Return values. Yeah, let's previous page, we used to void keyword, which indicates that method should not return a value. If you want the method to return a value, you can use a primitive data type such as int char instead of void and use return keyword inside the method. Static int method. This example is some of the methods two parameters. Results in a variable. For example, on games method overloading. So overloading versus overwriting is an important question to know. With method overloading, multiple methods can have same name with different parameters. Same name but different parameters. Multiple methods can have same name parameters. Go to the following example, which has two methods: my method plus method double plus method double x double y plus method int y. It just int is different. Like Java compiler. Java. Plus method. That's an interesting thing. My num1 is plus method 8 and 0. What if you pass ints here? Run. Yeah. That is still plus method 13. Bull. Oh yeah, it sees the yeah. How about we do this int this run. Incompatible types, possibly lossy conversion from double to int. Yeah, that's an error. Good. So what's overloading? Overloading means that multiple methods can have the same name with different parameters. Overloading, same name but different parameters. Scope, recursion. Code block refers to all the code within a curly brace. Block of code refers to all of the code within the curly braces. Variables declared inside a block only accessible by the code between the curly brace, only after the line in which variable was declared. Okay. Yeah. After. Declare directly inside method anywhere in the method following variable recursion, halting conditions. Loops can run into a problem of infinite looping. Recursive method can run into a problem of infinite. Yeah, if end is one of them, start some end. Okay. Java OOP. Damn, that's a pretty good Java reference. That is a pretty good study plan. What is OP? Yeah, another thing I want to go through is solid principles. Solid guides to solid principles. That's great. Solid intros by Robert C. Martin. Design, solid design. Yeah. By Robert C. By design principles, and these concepts were later built upon by Michael Feathers, who introduces the solid acronym, design principles and design patterns. So principles are warranted, changing what is solid and how does it help us with that? Single responsibility, open closed principle, list of substitution, interface segregation, dependency inversion. I don't remember that. So single responsibility. Single responsibility principle, as we might expect, this principle states that a class should only have one responsibility. Furthermore, it should only have one reason to change. How does this principle help us build a better software? Testing, a class with one responsible will have far fewer test cases, lower coupling, less functionality in a single class will have fewer dependencies. Organization, smaller, well-organized classes are easier to search than monolithic ones. Let's look at a class to represent a sample book. Yeah, in this code we store the name, author, and associated. Yeah, textbook. This is just a book. Let's now add a couple of methods to query the text. Replace methods that can direct to the book properties. Yeah, that's no good. Now our book class works well, and we can store as many books as we like in our application, but what good is storing the information if we can't output full text? Open for extension, closed for modification. Principal classes should be open for extension. Classes should be open for extension but closed for modification. In doing so, we stop ourselves from modifying existing code and causing potential new bugs in an otherwise happy application. Of course, one exception to that rule is when fixing bugs in the code. Constructors, getters, and setters. We launch the application and everyone loves it, but after a few months we decide guitar is a little boring and we could add cool flame patterns to make it cool and more rock and roll. And we flame color. Yeah. Super extends guitar for extension. At this point, it might be time to just open up guitar class and add a flame pattern, but who knows what errors might throw up in our application. Instead, let's stick to the open close principle and simply extend our guitar class, like literally extending. Liskov substitution. Liskov substitution. Next on our list is Liskov substitution. It's arguably the most complex of the 5 principles. Simply put, if a class A is a subtype of class B, we should be able to replace B with A without disrupting the behavior of our program. A is a subtype of class B. A is a subtype of class B. Replace B without A behavior. Jump straight back to the code, like car, turn on the engine and accelerate. Motor, car, engine. We had engine here. Engine on, turn on engine and accelerate. Implements keyword. So yeah, implements car. This is an interface, not a class. Interface car, class is subtype of class B. We should be able to replace B without A disrupting the behavior. Okay. There are called description an engine that we can turn on. We can increase the power. We're living in the era of electric cars. We can also implement an electric car by throwing a car without D. I don't know. The engineering and change the behavior of our program. This is a blatant violation of Liskov substitution. Accelerate, turn on engine. I don't have an engine. Yeah, turn on engine. By throwing a car without an engine into the mix, we are inherently changing the behavior of our program. This is a blatant violation of Liskov substitution. If class A extends or implements class B, we must be able to use A in place of B instead of B, and disrupting the behavior of our program. And this acceleration is crazy, blatant violation to fix with our previous 2 patterns. Possible interface segregation. Interface. what's the bear interface segregation? The I in solid stands for interface segregation, and it simply means that larger interfaces should be split into smaller ones. Larger interfaces split into smaller ones. By doing so, we can assume that implemented classes only need to concentrate about the methods that are interest to them. Well, this looks like a single responsibility thing. For example, we're going to try our hand as zookeeper, and more especially, we'll be working in the bear enclosure. Let's start with an interface that outlines roles as bear keepers, feed the bear, pet the bear, blah 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 blah. To avoid zookeepers, we're more than happy to wash the feed and behind. Yeah. But we're still all too aware of the danger of petting them. Unfortunately, our interface is rather large, and we only choose the code the pet bear. Let's fix this by splitting our large interface into three separate ones: bear cleaner, bear feeder, and bear petter. Now, thanks to interface segregation, bear care, implement methods that matter to us. Oh no, yeah, it's interface segregation. It's about interfaces, not classes. So a class can have multiple interfaces. It's just that those interfaces need to be small. Barefeeded dependency inversion. I don't get this thing. I think, but it just whatever. The principle of dependency inversion refers to the decoupling of software modules. I love this word, decoupling. This way, instead of high-level modules depending on low-level modules, both will depend on abstractions. This way, instead of high-level modules depending on low-level modules, both will depend on abstractions. To demonstrate this, let's go old school and bring live to, say it, machine. Standard keyboard, monitor, new standard keyboard. Oh, this is a really good example, man. Yeah, you can change your monitor. You don't need to be dependent on that. This code will work, and we'll be able to use standard keyboard and monitor freely within our Windows 98 computer class. Problem solved quite by declaring the standard keyboard and monitor with the same new keyword. We've tightly coupled these classes together. Yes, like this monitor, this exact monitor, not good. The machine. So we should give it through a constructor, keyboard, and monitor. Here we're using dependency injection pattern to facilitate adding the keyboard dependency into the Windows machine. Let's modify keyboard class, standard keyboard, modify standard keyboard class, keyboard interface, suitable for injection. Now our classes are decoupled and communicate through the keyboard abstractions. If we want, we can easily switch to the type of keyboard into our machines with different implementations. We can follow the same example of decouple the dependencies and are free to test our yeah. So yeah, principle of in refers to the decoupling of software modules. Instead of high-level modules depending on low-level modules, both will depend on abstractions. To demonstrate this, old school 80. I guess this is high level. I don't understand. So it's hard to test. We also use the ability to switch our standard keyboard class. Right, one. Keyboard. Yeah, keyboard interface. And this is a low. I guess the machine is a high level, and keyboard is a low level, and you don't want high level class to be dependent on the low level class. They both need to be dependent on the abstraction of I tried to use my best. I did my best to read. It's a good way of uh, I like to call it abstraction injection. Depends on abstraction. Abstraction. of Java class. I will just read over those stuff. Errors debugging. What else should I review? Yeah, data structures are gonna be asked, I know. Wrappers, yeah. Let's go through some Spring framework questions for interview and laconic answers. After this, I'm gonna take a break, take a small break, and then I'm gonna build a project in Java just for the language, of familiarity. Yeah. So a couple of things. What is Spring? Spring is a oh shoot. I forgot that I'm connected to this. So a Spring what is Spring? A Java framework for dependency injection, AOP, and enterprise app development. What is Spring dependency injection? Via constructor, setter, or field instead of a new. Yeah, new keyword, you shouldn't use new because new like strictly couples a high level class with a low level class. What is inversion of control? Objects are created and managed by the container, not manually. Bin scopes in Spring, singleton default, one per container. For new instance, each request session, sockets. Bin scopes in Spring, singleton by default, one per, yeah. Request session application web scope. So component, service, repository, and controller. Component is a generic bean. Service is a business logic. Repository is data access object. Persistence, MVC. Controller, MVC. Autowired versus inject. Autowired is Spring DI. Spring inject standard. What is Spring Boot? Opinionate framework for standalone Spring apps, which embed server and auto configuration. Spring Boot application is Spring Boot application configuration plus enable auto configuration plus compliance scan. Difference between controller and REST controller. controller and REST controller. Controller returns view like JSP. REST controller returns JSON or XML and combines controller plus response body. What is AOP? Aspect-oriented programming separates cross-cutting concerns from cross-cutting process like logging and transactions from business logic. Transactional usage manages transactional declarative methods. Spring Data JPA purpose simplifies database operations. With repositories and queries, difference between Bean Factory and application context. Lazy basic API, eager events, internationalization, and AOP. What is qualifier? Specifies which bean to inject when multiple exist. That separates what is Spring MVC flow, client, dispatcher serverlet, handler mapping, controller. Explain MVC. Model view controller, MVC model view presentation. Model holds data and business logic. View handles presentation. Live JSP controller, intermediary between model and view. Intermediary is business logic in is service classes of the model layer. Keeping logic out of controllers ensures testability. User controller, REST controller, user controller, get mapping, user's ID. Here's an example. User service, user service, user service. Yeah, I'm gonna take a little break now, and then I'm gonna come back and build Kafka with Java. Top stream.